Installing the lifting jig onto the bushing. The bushing on the left has been delivered to the bushing shop in order to be refurbished. The bushing on the right has already been refurbished and will be transferred to a different location. Large bushings, such as the ones here, are regularly moved in and out of the area on transport carriers, which are basically metal frame structures with supporting rests along the length of the bushing. The mounting flange of the bushing is itself bolted to the metal frame of the transport carrier to prevent it from being damaged in transit. In order to remove the bushing from the transport carrier, a lifting jig, as shown here, must be attached to the bushing so that it can be raised up from the transport carrier and also pivoted into an upright position for placement into a service well. The lifting jig has a crossmember on one of the sides that must first be removed so that the jig can be fitted onto the bushing while it lies on the transport carrier. Use a ratchet wrench with the appropriate size socket to loosen the bolts on each corner of the crossmember. Once loosened, manually remove the bolts, holding the crossmember to the lifting jig. Once the bolts are removed, lift the crossmember off with the help of another team member and place it in the appropriate position under the upper porcelain insulator of the bushing that has arrived to be refurbished. Place a sheet of cork padding over the porcelain just above the mounting flange to protect the porcelain from directly contacting the lifting jig when it is attached. Loop one end of a lifting sling, having the appropriate weight rating capacity, around the junction of the remaining crossmember on the lifting jig. Attach the other end to the hoist hook, and then turn the jig so that the remaining crossmember is on top, and the 4 rectangular plates, each having a hole near the inner edge, are facing north, and the jig rests on the floor.
What we're doing now is readjusting the choker that we're using on this sling to be able to pick up this jig in a balanced fashion.
Begin hoisting the lifting jig using the crane so that it can be positioned correctly over the porcelain on top of the sheet of cork padding.
Okay, I'm going to take it west. Okay, going south a bit. Okay, bringing it down. Somewhere in that area.
Using the appropriate size wrench, one team member can secure the bolt, while another team member uses a pneumatic air gun to loosen or remove the nuts that hold the flange of the bushing to the transport carrier. When loose enough, manually unscrew the nut and remove the bolt. Note, it may not be possible to remove all of the bolts if the weight of the bushing restricts the removal. Some bolts may have to be removed when the weight on the bolts is relieved after the bushing has been raised accordingly. Navigating the hoist hook on the crane is done using a handheld remote control. Large buttons on the face of the remote are used to move a load in any direction. Using the remote control for the hoist, lower the lifting jig in very small increments so that the metal frame of the lifting jig can be set into position whereby the 4 rectangular plates facing north can be attached to the mounting flange on the bushing. One team member can manually tighten the bolts with washers through the holes to connect the jig to the flange on the west side of the jig. Another team member can manually tighten the bolts with washers through the holes to connect the jig to the flange on the east side of the jig. In some situations, and depending on how closely the holes on the flange and the jig are aligned, it may be necessary to use different size bolts.
Yes.
In some situations, and depending on how much space there is under the bushing, it may not be possible to slide the crossmember under the jig to be able to attach it. In this case, it is necessary to raise the bushing using 2 slings that are attached to the flange's separate shackles. These types of situations make it a necessity that the bushing team communicate well with each other and function with a high degree of astuteness and agility. The transport carriers are not universal in design. The bushing presented here is made in Hebburn, England by the Trench Company, and the transport carrier was made by General Electric to transport a GE bushing. After the slings are attached to the hoist hook, the crane operator can slowly raise the hook only to eliminate the slack in the slings. Prior to actually lifting the bushing, the bolts that attach the bottom flange of the bushing to a plate supported by a metal arm on the transport carrier must also be removed. Use a ratchet wrench of the appropriate size to loosen all of the bolts. Once loosened, manually remove them from the flange. There may also be some bolts that are still in place attaching the mounting flange to the transport carrier. By raising the bushing incrementally, using the remote control for the hoist hook, the weight on the bolts still remaining can now be relieved enough to remove them. Use a pneumatic air gun to remove the remaining bolts that are still attaching the bushing to the carrier. If some of the bolts still cannot be removed, begin to slowly raise the bushing up off the transport carrier to relieve the weight on the bolts that remain. Attempt to remove the bolts again using a pneumatic air gun. Some bolts may have to be reattached in order to equally distribute the weight before they can be loosened. The bushing may have to be incrementally raised in order to achieve the proper weight distribution to remove the bolts. It may also be necessary to wedge a block of wood under the lower flange in order to take the weight off the bolts that attach the lower flange to a metal arm on the transport carrier.
There's a bolt in there. Yes, absolutely.
Use a ratchet wrench to loosen the bolts holding the metal arm to the frame of the transport carrier. Once loosened, manually remove the bolts until the metal arm and the attached plate can be disconnected from the bushing. Having removed all the bolts connecting the bushing to the transport carrier, detach the slings from the hoist hook and disconnect the 2 shackles from the mounting flange.
I'm gonna go too far. No. Now, place.
Reconnect the sling on the lifting jig to the hoist hook and slowly raise the lifting jig enough to be able to attach the cross member below the bushing. Slide the cross member that is under the bushing directly below the frame of the lifting jig so that it can be attached at each corner. Reinsert the bolts with washers into each corner and tighten using an open wrench of the appropriate size. Ensure all the bolts installed have been securely attached. Install and secure the bolts on both sides of the bushing.
We're tight all around on this side, Graham. Okay, just as long as it's snug. Snug? No.
Using a pneumatic air gun, fully tighten the bottom bolts that were used to connect the lifting jig to the flange.
That's plenty. That's perfect. Now we're just going to move to the top bolt.
Also, fully tighten the top bolts used to connect the lifting jig to the flange.
Yeah, and you can take the sling right off.
Lower the hoist hook to just above the lifting jig, and then remove the sling from it.
Graham wants to keep looking at the camera.
Remove the sheet of cork padding from the top of the bushing.
Next move, once you get back at it, pick up our jig.
Setting up the crane cables and attaching them to the jig. Attach a multi-point lifting beam to the hoist hook on the crane, and then lower the hook above the wooden storage container for the cables used to lift a bushing from a transport carrier. Attach the ends of the lifting cables to shackles on each end of the lifting beam, and begin lifting the beam to remove the cables from the container. Continue to lift the metal cables up and out of their storage container. Place an electric portable hoist close to and underneath the lifting beam with the cables attached to the ends. Lower the hoist hook on the crane and attach the shackle in the center of the lifting beam to the hook on the top of the electric portable hoist. When the electric hoist is secured to the center of the beam, the crane operator can begin lifting it off its cart, and then the cart can be removed. Choke a sling around the porcelain directly below the oil reservoir tank and the top shed of the bushing. Choke the sling by first wrapping it around the bushing, and then inserting one end of the sling through the loop on the other end, and then pulling to tighten it securely around the bushing. The cables on the electric portable hoist will be attached to the sling choked around the top of the bushing. Attach the cables suspended from the ends of the lifting beam to each side of the lifting jig. Each cable has a large loop at the end, so that it can be inserted into the open shackles on both sides of the lifting jig. Once inserted, each shackle is closed by inserting a bolt to connect the legs of the shackle together to secure the cable inside. When everything is attached and positioned properly, a second inspection is done of all the cables and connections to make sure it is set up correctly. Lifting the bushing from the transport carrier and moving to service well. The metal crane cables are attached to the sides of the lifting jig and extend to each side of the multi-point lifting beam suspended above the bushing. Lower the hoist hook of the electric portable hoist that's suspended in the center of the lifting beam, and attach the end of the sling choked around the top of the bushing to the hook.
Okay. So now I'm just going to do a little centering of this device.
The crane operator should make sure that the crane is positioned properly in conjunction with the bushing and lifting jig. This ensures that when the bushing is lifted, that it will be properly balanced and not sway. A separate operator using manual cable remote controls should control each hoist. The crane operators for the bridge crane and for the electric portable hoist should coordinate their actions by staying in close communication.
Okay, whoa, that's it. I'm already up.
Assemble and install 2 metal retaining rods into the 2 slots around the service well in which the bushing will be lowered into. When the rods have been lowered into the holes on one side of the service well, place a thick block of wood between the rods and the edge of the well. The wood acts as a stabilizer to prevent the base of the bushing from any impact with the metal floor around the rim of the well when it's being lowered. Begin lifting the bushing off the transport carrier so that it remains in a horizontal position.
Pretty good there. Okay, so okay, we're going to start making the left. Okay, do you want to let your end down just a hair? And there it is. Okay. You go okay to lift? Okay, now I'm going to start bringing it east.
When the bushing is above the transport carrier, move it eastbound to a position about 4 feet above the yellow line on the concrete floor. Begin tilting the bushing by lowering the bottom end, where the lifting jig is attached, and raising the top end, where the sling is choked.
Now the actual tilting is going to start taking place. Okay? So Graham, if you want, you can start raising your end. Yeah, I'll start taking it down at the bottom.
Continue raising one end and lowering the other as the bushing becomes more upright. The bottom end of the bushing should remain approximately a foot off the ground.
I'll try not to go up too much higher for you, Graham. It's okay. Okay. And stop. Stop. Okay. Do you want the little stool?
Yeah, maybe.
It's right over there. Graham needs a stool.
Depending on the size of the bushing, as it is being raised and becomes higher off the ground, the team member controlling the electric hoist may need to stand on a small set of stairs to be able to control the remote. Once on the stool, The team member can operate the hoisting device and adjust the bushing's position.
Okay, stop. Stop. That's pretty darn good, I think.
The bushing should be
Good.
stood up as straight as possible, so it can be placed in the hole with no difficulties.
Perfect. So now what we're going to do is we're going to swivel this around completely so that this low end of the flange makes contact with that.
The bushing is then swiveled and turned around so that the cross beams on the lifting jig are on the north and south ends, and the horizontal beams are on the east and west sides. The remote operator can then start directing and moving the bushing in a northerly direction so that it is lined up with the service well into which it will be placed. A team member should support it so that the bushing does not sway.
That'll be good enough for now. Okay, coming east. I'm going to start taking it east.
Move the bushing eastward towards the service well with guidance from a team member supporting to prevent it from swaying while it's being moved.
Okay, Graham, you can go ahead and open up that hole.
Remove the cover on the service well and roll it out of the way to a safe spot for storage. Center the bushing as much as possible as it is suspended above the well.
Yep. Okay, Graham?
Yep.
Taking it east over the hole now. I'm just going to center it perfectly as much as I can. That's pretty darn close right there. Now I'm going to have to come north just a little bit. That's pretty good right there. Okay, I'm going to be bringing it down.
And then slowly lower it down as it's being guided by a team member on either side.
Now I'll make a slight adjustment if I have to. Okay. Okay, going down.
Lower it to just above the wood block on the side of the well, and then slowly lower it to the floor after being assured it will clear the block of wood.
There's your drop.
When the bushing has been lowered and is securely in place, begin removing the shackles on the lifting jig.
Perfect. Perfect. Okay, that's good. So now you can go ahead and start undoing the shackles.
Removing the jig used to move the bushing from the transport carrier. Remove the cross-section side of the lifting jig first by using a socket wrench to unscrew the nuts and bolts holding it to the jig. There are 4 different nuts and bolts that need to be unscrewed and removed before the cross-section can be removed. Once removed, replace the nuts, bolts, and washers back into the frame so that they will not be misplaced.
This bushing is only put in this spot here because of the holes in the floor for just to put the rods and the board in place so it can be uprighted in a stable manner.
The cross-section is taken off from the jig and stored in a safe area away from the bushing. Use a pneumatic gun to take out the nuts and bolts that hold the lifting jig onto the flange. Using the rolling warehouse ladder with railings and the locking mechanism engaged, A team member should climb up the ladder and begin to remove the sling connecting the bushing to the electric hoist. The hoist hook may have to be lowered so that the sling can be taken off the hook. Once off the hook, it can be removed from the porcelain under the oil reservoir tank. After the cross-section on the north side of the lifting jig has been removed, the crane operator must lift away the remaining part of the jig. Team members on either side of the jig should guide the jig away from the porcelain to prevent any impact from occurring.
You should be able to go straight up to the tank. Okay, going west.
You want to drop it?
We'll drop it right here.
Move the jig to the concrete section of the floor and begin to move it southward while still being guided by team members. Undo the shackles on either end of the mobile lifting beam.
Okay, heading north.
North?
Slowly and carefully lower the portable electronic hoist onto the support railings on the storage cart for the unit. Disconnect the mobile lifting beam from the hook on the top of the electric hoist and wrap the remote cable for the hoist neatly and securely around the posts on the cart. Lower the mobile lifting beam into the wooden storage container on top of the cables that were used to lift the jig. And then remove the beam from the crane hook. Reattach the cross-section back onto the side of the lifting jig. Rotating the bushing when upright in the service well. Using a rolling warehouse ladder with railings and the locking system engaged, choke another sling over the top of the sling that is already choked around the porcelain under the oil reservoir tank at the top of the bushing. Ensure both slings are on opposite sides of the oil reservoir tank in order to optimize conditions for a balanced lift off the floor.
All right.
Attach the ends of both slings to the hoist hook. The crane operator
should
can
be good,
begin to
Graham.
remove the slack in the slings by raising the hook.
Okay, you ready?
Yep.
Okay, I'm going to lift it now.
In very small increments, the crane operator can slowly lift the bushing a few inches upwards. Any necessary adjustments are made to keep the bushing centered in the service well.
Okay, easy. I'm going to take it east a little bit, Graham.
A team member should support the bushing from swaying by holding onto the top porcelain with both
Okay.
hands.
Going to take it a little bit south.
Once the bushing has been raised out of the well and centered, the team member can hold on to the top porcelain and turn the bushing manually to its intended position. In this case, the capacitance tap will be adjusted to face west.
That's it.
A team member can then climb the ladder and detach the sling connecting the bushing to the hoist hook. initial Megger and low voltage electrical tests for capacitance and the dissipation factor. After the bushing has been lowered into the service well, a series of electrical tests must be performed to determine if the main insulation wrapped around the core within the bushing is still intact. If significant degradation has occurred, it may not be worth refurbishing. In order to perform the initial electrical tests, the capacitance tap cover is removed so that the voltage tap, also known as the cap tap, can be accessed. The first test is performed using a megohm meter, or Megger. By connecting a cable extension to the black lead, the extended cable can be connected to the conductor core via the threaded rod extending out from the top of the terminal at the top of the bushing. Using the rolling warehouse ladder equipped with handrails and with the locking mechanism activated, climb to the top of the bushing to the level of the terminal. Connect the cable extension to the threaded rod extending out from the top of the terminal on the bushing. After setting the selector switch located on the front of the Megger test unit to 1 kilovolt, the red lead is then connected to the bare metal of the flange of the bushing. Press the test button to activate the test voltage and take the reading digitally displayed in the display panel on the front of the Megger tester. A reading of greater than 999 megohms is a near-perfect resistance reading for the insulation in a bushing. After the Megger test is complete and indicates that the bushing is still in very good condition, additional electrical tests, commonly called the Doble C1 and C2 insulation tests, are performed in order to determine the integrity of the main insulation and the tap insulation within the bushing. To facilitate adequate transmission, a strand of 1/8 inch bare copper conductor should be tied to the threaded rod extending out from the top of the terminal on the bushing. Loop a section of strand around the rod twice, and then twist tie the ends together so that a connection clamp can easily be attached. The flexibility of concentrically stranded bare copper conductor makes it very suitable for uninsulated electrical connections. The capacitance and dissipation factor bridge used for the low voltage Doble testing is situated on a dedicated mobile cart. Connect one end of the high voltage lead that sends out the electric current, the red lead, to the high voltage terminal labeled C(H) on the capacitance and dissipation factor bridge. This terminal is at the top of the 3 terminals on the bridge. Then connect the other end of the lead, also red, to the bare copper strand wrapped around the top of the terminal lead. In order to make a proper ground connection to the bushing, it may be necessary to grind off the layers of paint on a small section of the flange, so that a section of bare metal is exposed. Once the metal has been exposed, connect one end of the ground cable, the green lead, directly to the bare metal on the flange. Connect the other end to the terminal labeled G on the capacitance and dissipation factor bridge. This terminal is at the bottom of the 3 terminals on the bridge. Connect one end of the low voltage cable, the black lead, to the capacitance cap. Connect the other end of the lead to the terminal labeled C1 on the capacitance and dissipation factor bridge.
Okay, this is the C1 test. We're going to test first for capacitance. So we put the switch to capacitance. Then we go to the capacitance section here and we start bringing it up. That's too far, so we're going to go back down. Then we fine tune with this knob here and we bring it to 0. Then we go to the dissipation factor and it's showing that it's very high right there. So we're going to try bringing it down and bring that to 0. We go back and forth because they affect each other. Now we're going to bring this up to 0. We go back to dissipation. And we finally reach a point where they both stay at 0. And that's your reading then.
Okay.
So this is going to be the readings that I take off of these two little gauges here.
Where do you take your reading from?
Right here, the numbers on this thing
Okay,
here
on
and
the-
those numbers here.
On the capacitance side.
Yeah.
That would
This
be-
one and this one. Like this one for capacitance, I take it from this one and here. See what you can just see the numbers there, like that's 3, 4, 5, 6, 7 on here.
Going counterclockwise.
Yeah. So you've got 4 right there.
Yep.
4.202.
I see.
Okay.
4.202.
Right.
That's in capacitance.
Right. Now that's also, you've got this multiplier.
Yes.
That multiplier is set at 100.
Okay, so you.
So now you got to do that.
multiply
So now
by
it just
100.
became 420.2,
Okay.
right?
Okay.
And that's, okay, that would be the capacitance reading.
Okay.
That's 420.2. So what I'm going to start doing is I'm going to start recording all of this information on this sheet.
The Bushing test sheet.
Yep. So we've got the serial number right here, and then we start the dissipation factors. This test that we're doing right now is C1.
Right.
Yeah, sorry, I am left-handed for writing. So the C1 test, the first reading here is the dissipation factor.
Right.
Okay, so what we'll do is we'll 173 here,
Yeah.
and the scale is 0 to 10. So we would write that in here, 0 to 10. Then so the uncorrected dissipation factor will become 1.73. Then we'd go to the capacitance right here,
Right.
and that's going to be off of this one. And you've got 4.202.
Right. Times.
So you would go 4.202 with a multiplier of 100. So you would put that here as well. And then you have 420.2. Okay. And the Megger, we already did that Megger test.
Yes.
We record that as well. And that was greater than 999.
Yeah.
Okay. On this one here, they ask about a ground shield continuity test. That's for a different type of bushing. It's not applicable to this one. So we do mark it off as NA, not applicable. And micro-ohm also is not applicable because micro-ohm testing is done only on breaker bushings. Okay, it's a resistance test. So that is not required as well. So we put non-applicable for that. And we'll just do that there.
The next test is the low ground GST test, where GST stands for Grounded Specimen Test. It is commonly referred to as the C1 plus C2 test. Disconnect the end of the cable that sends out the electric current, the red lead, from the pure copper strand at the top of the core conductor, and connect the lead that was connected to the cap tap, the black lead, to the pure copper strand.
Okay, now we're going to just switch this to low ground grounded specimen test. And then we're going to start the whole procedure over again exactly as we did with the first step. So we're going to turn on the power.
Get everything with your right hand if you don't mind.
Yep. We're going to turn on the power. We're going to do the capacitance test first. We're showing low right now, so we're going to try going until we get a reading. Now this gauge here only goes up to 11, so it didn't work there. So now we're going to start going higher with our multiplier
Right.
to try and get a reading.
There you go.
There we go. We've got our reading
Back
there.
off.
So now we start backing off.
Nope, not
Okay.
far enough.
Now we got to go this way.
Yep.
And there we're at 0. Now we do the DF test. I'm going to try it here. There you go. And we go back to the capacitance. And there we are, we're staying at 0 now. So that's our actual reading now. So for dissipation factor, we actually ended up on a chart 0 to 1, so 0.475. And here we've got 10.203,
So it's
Molt-
0.10.
0.001. So that's going to be 10,000, 10,203.
Well, this is 10.20, right?
203. Whoops. Yeah.
10.20.
When the test is complete, remove the connections from the bushing.
Okay. So we're there. We're going to do a capacitance test first. So we're going to. This is a grounded specimen test, and the low is now grounded to the flange. So that's why it's in this position. Now we turn on the power. We're going to do a capacitance test first. So we're going to. We're at 500 here. It's too high. So that's where we have to be there.
Yeah, and then back.
We're going to. Oh, is it not on?
No, it's on.
Oh. Okay, so.
There you go.
Okay, so now we're going to do the DF part of it. Back to the capacitance. It's pretty much right on. So there's your zeros
All right.
for both settings. So what you actually have now is the 0.01.
0.065.
So actually now what you see you've got is 9.787 with a multiplier of 0.001.
0.09.
And if you add the 420, you should get the same answer. So
0.09.
rightfully it's going to be 9,787, okay? And that other reading there is 10,203. So this is what you would do. You would put 10,203. And this one here will be 9,787. And if you take this, if you take your C1 and your C2 and add the two together, you will come out with your C1 plus C2 test. See? Within a few picofarads. So just to
You're
show you.
You're 500 out.
So if you do 9787, let's see, 9787, clear. 9787 plus 420 equals 10207. You had 10203.
Okay.
See?
Wow, that's pretty good.
It's that's just a. So that's your actual test there. So now I'm just going to write it all in, all the information. So we got the dissipation factor again, 0.46. That's 465, and it's also 0 to 1, which makes it 0.465. Your reading here was 9.787 with a multiplier of 0.001, and that gives you 9,787. And that's your testing done for that. The rest of this sheet here, we're going to put in all the pertinent information to this bushing. We're going to put in the type of bushing that it is, the catalog number, the production number that's going to be created for this job, the report number that we're going to create for the job was all going to be put in here. And everything we do from here on in is going to be recorded.
Initial high voltage electrical tests for capacitance and dissipation factor. For the C1 test, begin by connecting one end of a ground cable to the bare metal of the flange and the other end to the ground rod for the building. Also connect the ground cable for the biddle to the bare metal section of the flange on the bushing. Attach one end of the low voltage lead cable to the low voltage blue terminal on the side of the biddle tester. Attach the other end of the blue low voltage lead cable to the cap tap. Place a block of wood on the metal floor, and leading over to the flange and on top of the wood and the flange, place a rubber mat so that the cable attached to the cap tap rests on the mat. Attach the thicker orange high voltage lead cable carrying the current directly to the top of the conductor rather than the copper strand. Support the weight of the cable on a sling suspended from the hoist hook. Ensure that it is safely in position above the terminal on the bushing. Turn power on switch on biddle. Turn on the high voltage switch. Press the UST test mode button for grounds red and measures blue option on the low voltage lead configuration panel. Press the high voltage on switch and the red light goes on above. Rotate high voltage control knob to set point of 10 kilovolts, indicated in the digital display window. And then press the Measure button on the operation panel. The test is complete when a set of results appears in the display window and the red operation light goes out, followed by the red high voltage light, indicating that the high voltage switch has shut off. Enter the serial number on the form titled Double Insulation Tests Bushings for initial testing. Make entries in the spaces provided for watts and percent power factor. Also enter the readings made for temperature and humidity on the form. The temperature and humidity at the time the test was conducted are important factors that can affect the test results. The results of the C1 test can be printed out, and because the tests are conducted using much higher voltage, the results are much more accurate than the results from the first C1 test conducted at 40 volts. In this case, the results indicate that the bushing is in very good condition. Label the printed record of the test results with the name of the test, as well as the serial number of the bushing. Disconnect the high voltage lead from the top of the core conductor and prepare to conduct the C1 plus C2 test. Disconnect the low voltage lead from the capacitance tap and reconnect the high voltage lead in its place. Connect the low voltage lead to the pure copper strand at the top of the conductor core and support the cable using a sling suspended from the hoist hook above. Unravel the wires on the floor from each other to prevent stray current from interfering with the test. Note that 2 team members hold permission switches in their hands during the testing, and either one can stop the testing at any given time. Manually turn the power switch to on, and the white power switch light goes on. The yellow open ground light next to the ground terminal goes on briefly and then goes off. Press the GST test mode button for guards red and grounds blue option on the low voltage lead configuration panel. Press the high voltage on switch and the red light goes on above. Turn the high voltage control knob to the set point of 5 kilovolts indicated on the digital display window. Press the measure button on the operation panel and the red light beside it goes on. The test is complete when a set of results appear in the display window and the red operation light goes out, followed by the red high voltage light indicating that the high voltage switch has shut off. Press the first button on the left under the digital display to print a copy of the test results. View the test results as they appear in the display window. Disconnect the low voltage lead from the top of the conductor core and connect it to the flange in preparation to conduct the C2 test. The high voltage lead will stay connected to the capacitance cap. Manually turn the power switch to on, and the white power switch light goes on. The yellow open ground light next to the ground terminal goes on briefly and then goes off. Press the GST test mode button for guards red and grounds blue option on the low voltage lead configuration panel. Press the high voltage on switch and the red light goes on above. Turn the high voltage control knob to the set point of 5 kilovolts indicated on the digital display window. Press the measure button on the operation panel and the red light beside it goes on. The test is complete when a set of results appear in the display window, and the red operation light goes out, followed by the red high voltage light, indicating that the high voltage switch has shut off. Press the first button on the left under the digital display to print a copy of the test results.